Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is the reaction of epoxide, actually epoxide opening. So it's a pretty easy example, student. You can see you have to say what is the major product of this reaction, and here four options are provided. One of them is right. That's why I request you, student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. And don't hesitate whether your answer will be right or wrong, because self-evaluation is essential for improvement, and that's why you should try. I believe you have tried by yourselves. My turn to give you the right answer. Student, look at the problem very much carefully. As I told at the beginning, epoxide opening, so I have given the first clue. Actually, epoxide can act as Lewis base because it has two lone pairs of electrons. It's a cyclic ether strain molecule, three-member ring. So its opening is preferred. Point number one. Second, in reagent, what is provided? Bismuth triplet X water. This bismuth 3 plus E, student, actually a Lewis acid. And obviously such kind of reaction, it is better to carry anhydrous DMF. And you can see here what is the reaction time? 1 hour. Because it's a very quick reaction. So anhydrous solvent may improve the yield of this reaction because there is some crystal water of crystallization. X water is written. It's a crystal water, you can consider. So what happens? The first step is the Lewis acid base adduct formation. Means this lone pair of electron is coordinated to this bismuth center via coordinate covalent bond. Now this lone pair donation will increase some electron deficiency of oxygen, because oxygen is electronegative, so it's preferred to keep more electron density on itself, but it has given its sum of electron density to bismuth center. So what will happen? It will pull more electron density through this carbon oxygen bond, obviously, and consequently both this carbon will be delta plus. Not only that, this will also be delta plus. Now question, in which case which carbon is more electron deficient or having more delta plus character? If you look at this side, student, it is adjacent to methyl, so stabilization is not that much compared to the other side, which is, this is actually a benzylic position. And we know benzylic carbocations are relatively more stabilized. I repeat, student, the word relatively more stabilized. Why I am saying relative? Because all carbanion, carbocation, carbene means radicals, all are reactive intermediates. They are not stable. But when we talk about them, we did talk about their comparative stability. That's why it is better to pronounce relatively stabilized. So these benzylic carbocation is relatively stabilized because of the plus R effect of this phenyl group. It's resonance stabilized, fine. So that's why the bond opening will happen from this side. So it opens and it produces these benzylic carbocation, you can see, it's relatively stabilized. Now, but reaction will not stop here. What will happen? These oxygen will push its pair of electron, and these hydride will migrate here, and charge will be neutralized and will produce this ketone. Now you can see that, sir, why hydride migration, why not ketone? Because it was in the same carbon, means this methyl, it was in the same position, say attached to same carbon. Because the migratory aptitude, student, the migratory aptitude of hydride is more than aptitude is more than methyl, because the small size of hydride and it can handle the positive charge efficiently, so its migratory aptitude is better. Fine, small atom migration is easier. In this way, it produces this ketone. You can see such kind of thing in this alkyl migration versus hydrogen migration in Baeyer-Villiger oxidation, or sometime in case of pinacol rearrangement type of reaction. So lots of things. Now, so the most important question, why bismuth 3 plus behaves as Lewis acid? Because here you can see the what complex we have taken, bismuth triplet. So triplet is a stable anion, so that's why it's significantly ionic, and in +3 oxidation state also it's electron deficient. Another reason, see, bismuth have one very common phenomena, that is inert pair effect or lanthanide contraction. What does it mean? Before bismuth there is a filled F electron, means 14 F electrons, and these F orbital have poor shielding of nuclear charge. Consequently, the outermost valence electrons are strongly attracted by that central nuclear attraction force. Means bismuth became stronger Lewis acid, because whenever its electron deficiency became dominant. You can see this size comparison, means lanthanide contraction, due to lots of studies are there. I'm not going. So because of this inert pair effect or lanthanide contraction, bismuth behaves a better Lewis acid, bismuth 3 plus. Now, so what is the answer here in this case? In this case, the answer you can see the ketone, as I told, option A, and you can see the yield of this reaction in 1 hour 77%, significantly higher. Now, so this is the answer. Now, if you don't know the answer, how can you come up the right answer? Less than 30 seconds. First of all, you need to understand there is bismuth, because this water doesn't react, it's a water of crystallization, and DCM is a solvent. So only bismuth 3 plus will react with epoxide oxygen, which can act as Lewis base. And actually this reaction is nothing but epoxide opening in presence of Lewis acid. I have already discussed a dedicated lecture on epoxide opening. Please visit for better understanding. Now, so in this case, epoxide opening in presence of Lewis acid. So carbocation will be an intermediate electron deficient in this Lewis acid. Now, where the carbocation is stable? Obviously this position. Okay, and another thing, I haven't provided any water and no alcohol option is given also, so you can understand it's a ketone. So if these bond open, then where the carbon oxygen bond will be there, carbon oxygen bond will be adjacent to methyl group. This part if you understand, then this option B gone, this so B gone, and I haven't provided any heating, so this alkene preparation gone. And second thing, that methyl group has less migratory aptitude than hydride, so this option gone, so only one option left, this is A, so this is the right answer. So in conclusion, whatever we learned, that epoxide is a strained molecule because of its 3-member ring, and this epoxide can act as Lewis base, and it can coordinate with Lewis acid like bismuth 3 plus, and epoxide coordination makes the adjacent carbon atoms means electron deficient, and sometime ring opening happens and it produces carbocation. And by the way, carbocation can undergo rearrangement reaction to produce more stable carbocation, or it can undergo migration also. Okay, so you can see here that is during the migration of different group, generally hydride get more preference over other group because of smaller size, although there are some exception. I'm not going. So this is the end of discussion. I believe this video will be useful, and I thank you everyone for watching. And if you really consider the content of my channel is worthy, then please help this channel to grow. So stay happy, stay blessed. See you in my next video. Bye bye.